Hello and welcome to Cup of Cosmology, the place for all your questions about the universe. My name is Diana Hooper, Charlie to friends. I'm a theoretical physicist currently doing a postdoc at the Helsinki Institute of Physics over in the University of Helsinki in Finland. And I'm a cosmologist, so that means that I study the universe, the contents of the universe, how things evolve, how things interact, cool stuff happening inside the universe. I love being a scientist and I love chatting to everybody about all of the cool things I get to work on. So, for anyone who doesn't know, Cup of Cosmology is an interactive stream. The idea here is that you people can ask me anything you want about physics, about cosmology, about astrophysics, about the universe, about myself, about academia. You can ask me anything you want, and I will do my best to answer. This means that there is no topic, there is no direction to the stream. You all get to decide what we talk about based on your questions. I decide what topics or what direction the show goes in, but it's very much up to the questions that you ask. I see we have some of the regulars joining already. Scott and Brett, great to see you. Welcome. As always, great to see you here. For any first-time viewers, welcome. For any regulars, welcome back. If you haven't done so already, please do leave a comment, like the video, subscribe, do all of the usual YouTube stuff. It really, really does help boost engagement, and I appreciate when you press all those buttons and make stuff happen. It really, really does help. So I know some of you do that, so thank you. I really appreciate it. It really does help. James, great to see you as well. I see we have some more regulars coming in. That is excellent, as always. I'm always so happy that after so many years, it's coming up on 9 years of Cup of Cosmology now, almost 9 years. And some of you have been here for 9 years, and you still tune in almost every week to listen to me ramble about the stuff that I find interesting in the universe. So it's really great to have you all back here. And for any first-time viewers, welcome. If you're a long-time lurker, feel free to leave a comment. Doesn't matter if it's not a question. If you have questions, great. You're also welcome to just say hello and lurk in the background if that's what you prefer. And I feel like my background is somewhat off today, so I'm just gonna, well, not my background, just my camera angle. That's better. Just slight minor adjustments on the camera angle because it was just slightly off. Hey, Paul, great to see you as well. Happy Sunday indeed. It is Sunday, my favorite day of the week. I love Sundays. Sundays are a good day to make good food, do not much, and tune in for your weekly Sunday science. Who doesn't like Sunday science? Yeah, you'll stop coming when all of the mysteries are solved. The day there's no more cosmology to do will be a sad day. But unfortunately, that is going to be quite a long time away because there is still so much we don't understand in the universe. I always start by saying I'm a cosmologist. I study the universe. But really, there is a lot we do not know about the universe. Like, we don't even know what 95% of the universe is made of. Everything you see, everything you're accustomed to, everything from me, the stars, my tea mug, my phone, my plants, all of this is normal matter. But normal matter is only 4.9% the energy budget of the observable universe. There is another 26.2% that is in the form of dark matter. Now, dark matter is this weird type of matter that interacts gravitationally but doesn't interact via the electromagnetic force. This means that dark matter is invisible. We cannot see dark matter, but we can feel its presence due to its gravitational interactions with other objects. And then we have dark energy, which counts for 68.9% of the energy budget of the observable universe. Dark energy is this weird type of energy that is driving the accelerated expansion of the universe, and that is pretty much everything we know about dark energy. So yeah, I'm a cosmologist. I study the universe, but there is really 95.1% of the universe that we can't see and that we haven't figured out what it is yet. And that 4.9% of normal matter still brings up a lot of questions that we also haven't answered. So Paul, you said you'll stop coming the day we solve all mysteries. I think it's still going to be a while before we figure out this 95% that we don't really understand of the universe. And that's not even considering things like, black holes that we don't know much about. There's still so many open questions in cosmology. We don't know why the universe exists. We don't know why there's more matter than antimatter, why the universe looks the way it does. We don't know how supermassive black holes are formed. There are still many, many, many mysteries to be solved. So I think it's going to be quite a while. If you're coming on Cup of Cosmology until the mysteries are solved, we're going to be here for a while because I don't think we're going to find all the answers anytime soon. And that is the fun thing, right? That is what makes science really fun, that we know that we might never find the answers. And that's part of the fun. And sometimes we do find answers. And often when we find one answer, it opens up a whole bunch of questions that we didn't even know to ask. So usually more than finding an answer, you find one step in one direction and then you suddenly have everything, all the new things to figure out. Hey, Lethargo, great to see you. Welcome as well. Yeah, Scott's saying here 9 years. Yeah, it really has been almost 9 years. The first Cup of Cosmology stream was middle of August 2015, which is coming up to 9 years. At the time, it wasn't called Cup of Cosmology. That was just me on my Periscope days. But the title was pretty much the same. The title then was I'm a cosmologist. Let's talk about the universe. That is pretty much still the title. Just the name Cup of Cosmology appeared a few years back. But yeah, it is coming up to 9 years since I turned on my camera for the first time. It's like, oh my God, what do I do? What is a live stream? How do I talk to people? And some of you were there for that, maybe not for the first one, but you were there for those early days and you're still here. And that is amazing. Thank you to everyone who stuck with it for 9 years. And thank you to the first time viewers or the people who have only been around for 3, 5 months, however long you've been here. You are welcome on Cup of Cosmology. Okay, I see we do have some questions here. There's a question from Ange of what do I think of the NASA Chapia Life on Mars simulation? What does NASA hope to learn? I have absolutely no idea what that is. I have not. I have heard of that one, but I currently can't remember what it is. But there are different types of simulations we do. Somewhere we try to simulate what it would be like for people to live on Mars, and then we can usually go to deserts and build these kind of Mars enclosures that would replicate what astronauts would experience if they were living on Mars. And that helps us figure out the conditions that these astronauts will be subjected to and the psychological effects of living in such conditions. Other types of simulations we might be doing is trying to figure out how life could have evolved on Mars, or if Mars at some point could have had life. Now, we generally do think that I think that I really need to take care of the little baby flies that my plants have attracted because they keep bothering me. Yes, we do think that they use at some point there could have been some type of life form on Mars because we know that Mars used to have an atmosphere. That atmosphere has been stripped by now, but Mars used to have a stronger atmosphere. And we've been able to find evidence that there used to be some type of water bodies on Mars. We know that Mars has the 2 frozen caps. So there is a possibility that at some point Mars had the right conditions to have microscopic life forms. And that is also something that we try to simulate to figure out how life could have evolved on Mars. But I see, Ange, you've just added follow-up details. Thank you for that. So it ended today. It's a 1 years in Mars type environment. Yeah, so these are the simulations that they do on Earth to kind of see how the astronauts would experience living on Mars. So often what happens is they take a desert that simulates kind of the orange reddish landscape, and they build these enclosures. And the enclosures really are meant to reproduce what we currently have the capacity to build on Mars. Within these enclosures, the astronauts have to live inside the enclosures the entire time. There is recycled water system, there's recycled air system. Generally, it tries to be as accurate, as close of a reproduction as possible to what the astronauts or scientists would experience if they were actually on Mars. Anytime they leave this enclosure, they need to put the spacesuits on. They need to really act as if they are on another planet that doesn't have a breathable atmosphere. The things that we hope to learn by doing these simulations is, on the one hand, to prepare astronauts so that if we actually get to go to Mars someday, they'd be ready. But the other main thing is to figure out the effects on mainly the psychological effects of living in that environment. We know what astronauts on the International Space Station go through. We know what short-term tests on the moon look like, short-term visits on the moon. But if we're thinking about having somebody on Mars for 6 months to a year, maybe even longer, because it's going to be a long round trip, so you kind of need to have them there for a while. That is something that is going to have really big psychological impact on people. You have people living in close quarters. So it's something that is quite a different environment to what astronauts are used to being in, or what we're used to being in. So these kind of Earth-based simulations are the closest thing we can get because we can't go to the moon. So it's kind of, we don't want that the first time the astronauts are in this situation is when they're stranded on another planet. It's good to have the preparation. So I'm not sure exactly what the goals of Chapia simulation were, but usually these things are done to simulate the overall process, the psychological impact on the humans themselves. So it's very much a human-centric experiment. There's also the idea of, can they grow their own food in certain conditions if we replicate the conditions of Mars as closely as we can in a controlled environment. And it's also, I think it's a general part of the scientific process, right? You don't want that the first time you do something is when there's a high risk. You normally try to do it in a controlled situation first, and then eventually you try to do it, you gradually build up to doing it in the real life situation. So also another test that astronauts frequently do is doing underwater tests where they dive to the bottom of like really dense pools or really deep pools in full space gear or diving gear in this case, and try to like repair things and do timed experiments underneath the water. And this is also just kind of the pressure environment, because realistically astronauts are not going, if they're going to space, they're not going to be doing much underwater. But it gives the idea of, working in those suits, trying to do experiments where they can take off their gloves, where they know there is the outside pressure difference, where they have to rely on oxygen. So it is not the same as being in space, but it reproduces some of the circumstances. And so then it can also kind of allow the astronauts to figure out if they're ready to be in the real life situation, if they can handle these other situations. That's also something to consider, that if you want to be an astronaut, that's cool. Part of the training does involve being plunged into a swimming pool and doing experiments at the bottom of a swimming pool, which is, to me, sounds more terrifying than going to space somehow. So that is an important thing to consider if you ever apply to be an astronaut, that underwater simulations are part of it. Now, of course, there are some things that we cannot reproduce on Earth. For an example, the low gravity environment, the effect that this leads to, the effects of that low gravity environment on the body. And this is something that Abyss, hi, by the way, Abyss, I didn't say hi when you came in. Hey, Abyss, great to see you here. Great to see you on time. I know you come in a different points sometimes. Great to see you here. So yeah, as Abyss is saying, it's not just psychological. There is a low gravity. There is a problem that has on bones. There is the whole thing of, you know, what is it like to be in a zero-G environment for such a long time? And that is something that is quite hard to simulate on Earth. That's something that we can simulate for short periods of time by doing things like launching planes that kind of free fall around the Earth for a while, and then you can simulate these zero-G environment. But these low gravity environments are quite hard to simulate when you're on Earth. Now, of course, when they're doing this year-long Mars simulation, they will also simulate the time delay. So the communication with the outside world has this delay, unless, of course, there's a major emergency, in which case they can kind of pause the simulation. But usually they add this in as well. If someone were actually living on Mars, there would be a communication delay with Earth due to the fact that it takes a while for signals to travel back and forth. So when they do these Earth-based simulations, that is also something that they factor in. There are also these environmental conditions. So what can be controlled is controlled, but you still can't really reproduce 100% what it's going to be like to be on Mars. Coming from a base fun fact, one of your former classmates, who's now a postdoc at NASA, is doing confined Mars mission simulation. Yeah, that's very cool. There's quite a few people who do this kind of Mars simulation, and it's really cool. There's some people who do it for a week. There's people who do it for the whole year, and it really does help NASA and the different space agencies kind of prepare for the eventuality of having a base, either if it's on the moon or Mars. Scott here is saying you should work on a moon base before Mars, simply because it's always right there, not potentially on the other side of the sun. That is true. Personally, I think a moon base should come before a Mars base. However, then there's a question of what's the objective, and does building a base on the moon fulfill that objective? In any case, we are quite a few years away from either having a base on the moon or especially having a base on Mars. These are all very far away things, but it's good to start preparing now, because it's better to have already done all of the simulations once we have it built, rather than later be like, oh wait, we didn't prepare for this. So yeah, these simulations are really, again, I have not read about the specific one that Anja asked about, the Japir one that ended today, but in general, they're about preparing for these missions, for these future missions to Mars, to the moon, partly studying the psychological effects, and just in general how the astronauts would experience this situation, trying to reproduce it as accurately as possible. Of course, there's some things we can't reproduce, like the gravity, and that is going to be a big factor. NASA has done some really cool experiments to see how being in space or being in orbit affects human physiology. It's something that most astronauts on the International Space Station have to do. Some of the experiments are about growing food, some of the experiments are more scientific ones, and some of the experiments on the International Space Station are really about the human body, physiology, and the impact of being in space. One of the biggest experiments NASA did in this regard was with two astronauts who are twins, Mark Kelly and Scott Kelly. They're twins, very similar physiology, obviously, very similar genetics, both trained as astronauts, so both had the same training. And they did an experiment where one of them was on the space station for a year and the other was on Earth for a year. And they were doing the same type of tests, the same kind of treadmill tests, fitness tests, while one was in space and one was on the ground. And then when the one that was in space came back, they did a series of tests as well to see how much their physiology had changed over the course of the year. And then they could compare in kind of a very controlled situation where they had the twins, so very similar physiology, very similar genetics, almost identical genetics. And then they can really compare how the body of the twin who was on the space station compares to the body of the twin who was here. And that is a really useful experiment to see the impact of long-term exposure to zero G, to being in that environment, the impact that has on the body. It's very, very cool. We can also go down, yeah, it's a real life twin paradox. You can also go down some very cool avenues there of the, we can get into the biosciences here and biophysics, which I think is a super cool topic, which is kind of like how does the physics of how our body behaves in different circumstances. Like, we have evolved to be on this planet. Our bodies have evolved to be under a specific gravitational force. Our bones, our muscles, our whole musculoskeletal system is adapted to the gravity we have on Earth. When you send astronauts to space, there is the big problem that their muscles are no longer doing their kind of what they're supposed to be doing because you're in a zero G environment or a low gravity environment. So then your muscles, your whole skeleton, your whole body doesn't need to kind of work as hard to keep you upright because you're no longer fighting gravity. This can actually lead to things like bone atrophy and muscle atrophy. And this is also why the astronauts on the space station have to go through a really strict training regime. There's several hours a day of physical activity to keep their bodies active because it's such a different environment. So it's really, really important to do these ground-based experiments in order to really figure out what we can about how space travel is going to affect humans, so that then when these humans are actually in that situation, we can focus on the things that we haven't been able to control for, like the bone density, the muscle atrophy, which is something we are still trying to understand. But it's really hard to reproduce this zero G environment for long periods of time without actually sending somebody to a zero G environment. So yeah, that was a very long answer, but it's a very cool question. Just want to make sure I caught all the follow-ups to this question, and then we'll go back to the other questions that were asked at the same time. Super good questions came in at the same time when we jumped on this one, but I will go back to the other one. So let me just check the comments and the follow-ups to this. There's a comment by Lethargo, I suppose you could test some kind of logistics in addition to psychology. Yeah, the logistics of how, especially with the delayed communication, like how they would behave in this situation. And they have to prepare for they plan these simulations assuming the astronauts have everything already with them. They're not going to get weekly deliveries from their supermarket. They go with space food, with everything, really trying to simulate what they would be doing if they were on Mars. So they can't just call up and order pizza, unfortunately. They also have phone calls limited. There's always a delay. It really is trying to reproduce it as accurately as possible. Let's see. There's a comment from Paul. I spent a year in Mars-like environment, and all I got was this lousy T-shirt. Yeah, and probably some interesting psychological experiments to come. But yeah, it very much does indeed sound like the Armageddon training. So, as a general rule, if you see something in Armageddon, the film, assume that it is not accurate. That is, I love Armageddon. It is a silly film. It is the whole premise, the whole plot, absolutely ridiculous, but it's still funny. But it is probably, as disaster films go and space films go, Armageddon is probably the least scientifically accurate one out there. And that's saying something. But yes, do not take Armageddon at face value. It is fun. but it is absolutely not in any way a reflection of reality. But that's not why we watch it. Why we don't watch it pretending it's a documentary. We watch it for fun. Let's see. There are more comments about the Mars experiments and moon bases. Hey, John, great to see you. I still owe you 2 emails. I am still very aware of this, John. Every time I see him, like, I need to reply to your emails. But hello, good to see you here again. There was a comment from Prath. Do you think the first person to set foot on Mars is already born? Now, that's a very interesting question because there are several layers to that. Are you asking, like, do I think we're going to go to Mars within the next 50, 60, 70 years? Or is the question, are we going to be able to extend our life beyond that so that by the time we get to Mars, we're living 120 years? I know that you probably meant the former rather than the latter. Uh, Realistically, I think we're probably about 25 to 50 years away from being on Mars. So I genuinely think that the first person to set foot on Mars, the first human, modern day human to set foot on Mars, I think they've already been born. Yes, I generally think there is a person out there somewhere in the world, or people out there somewhere in the world, who are going to be the first ones to go to Mars. I do think that this is within our lifetimes. I think it's something that we will see within the next 25 to 30 years, maybe a bit more, but I think 25 years is definitely doable. Yeah, I think we are absolutely getting there. So yeah, I do think the first person to go to Mars is already out there. I know there's some people who are already planning for this, already thinking, like, what can I do to get ready to for when NASA, ESA, JAXA, whichever space agency gets there first, when they put out the call for astronauts with the idea of going to Mars. There are people already thinking about this and planning this. So yes, I do think that is going to happen. Yes. There's another comment from the Thurgo here. Since humans have only spent long times in full Earth gravity and orbital weightlessness, I'm curious how the effects of lower gravity on the Moon or Mars differ from the effect of weightlessness. This is something, again, that is really difficult to reproduce, but there is a big difference between being on Earth gravity versus being weightless in the International Space Station and being on the Moon, which is somewhere in between. If you were on Mars, you would have less gravity than on Earth, but more than on the Moon. So then you would probably get less overall effects or fewer effects on the body. Like, there wouldn't be as much muscle atrophy, but it would also feel extremely different. And it's something that is very hard to simulate and to model how this will affect the body without actually going there and doing this. But that is something that they're trying to do. The International Space Station gives us a basically weightless environment. And we know the gravitational pull or the gravitational effects of being on Earth. Moon, Mars will probably be somewhere in between. I think a more interesting idea would be, what if we go to a planet that has a stronger gravitational pull than the Earth? How would that affect our bodies? That will feel like a constant pressure weighing down on you. Would that be similar to being in a high pressure environment, for an example, at the depths of the ocean? Would that have similar effects where you just feel like the pressure is on your body, or would it feel different? I don't think that's something we can really answer right now, but that is also a really cool idea of what would happen if we took an astronaut and put them in a situation that had 5 times the gravitational pull of the Earth. Yeah, and this is something we can kind of think about, because there is the nice thing that we can think about gravity. Let me just check the comments again here at the bottom. I see there is a CMB question. I will absolutely get to all of these questions as well. Just sticking with this topic. Yeah, so we can kind of there is a nice thing that gravity can be interpreted as acceleration. We know, thanks to Newton's laws, that force is equal to mass times acceleration. F equals ma, which means if you have the force of gravity is basically an acceleration that happens. So this is something that we've also been able to simulate in some situations. You might think of people flying planes, those fancy planes where they do cool maneuvers, or even Formula One pilots. And you might hear the phrases thrown around like they've reached 5G, they've reached 4G, they've reached this many G. Now, G is basically the equivalent of the gravitational pull that we feel on Earth. So if someone is traveling with an acceleration of 3G, that means that they're feeling an acceleration or a force on their body that is 3 times that of gravity. We know that with training, people can withstand 5, 6G. Some people have gone up to 9G. We know at some point it knocks you out. But this is in very specific situations, and it's not something we can sustain, like keep that person at 5G for 10 minutes to do tests. That is something that is the body is just not equipped to deal with that yet. And we haven't been able to do really controlled experiments like this. So when we talk about, or I was just saying, like, what would it feel like to go to a planet with higher gravity? In a sense, we can reproduce this with these experiments with acceleration, bearing in mind that that is a small time interval and not prolonged exposure to this situation. But it does allow us to get an idea of what it might feel like to be in that situation. Of course, then there's a whole thing that with acceleration, we're talking about a body in motion, and then your body feels the whole motion, which is not directly the same as being stationary on a planet with a strong gravitational force. So there is nuance to it. There's a lot of nuance, but it is a super cool topic. Keeping with space exploration. Comment from Abyss. Speaking of space exploration, I get dumbfounded as to why there are no active missions to do Venus habitation. I think the big problem there is Venus's atmosphere is ridiculous, is like ridiculously big compared to ours, ridiculously strong. And that means that Venus is actually really, really hot. So even though Mercury is closer to the sun than Venus, so, if we consider the sun, the planets are ordered as Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and dwarf planet Pluto at the end. So even though Mercury is closer to the sun, the surface of Venus is actually hotter because of the atmosphere and the huge amounts of pressure. We have sent 1 or 2 probes to Venus's surface, and they basically burnt up. I see that you had the follow-up comment there. At some altitude, floating habitats are possible. I think then it comes down to you basically want to put something in orbit around Venus at the right distance so that people can live on it. It's technologically quite difficult to do that. And Venus has the much higher risk. Mars has the kind of good thing that there's no atmosphere. It's very Earth-like in some regards, and we have been able to send probes to the surface to take data of what it's like on the surface. The probes that we've sent to Venus, by the time they get far enough down in the atmosphere, they burn up. So Venus is just a lot more dangerous and a lot more difficult to build stuff around and to do tests on because it's so hot due to the high pressure because of the atmosphere. There's also some gases in Venus's atmosphere that we know are not good for humans. So that's also an added issue there of how would you build this habitat? How would you get it there? How would you get it in a way where you can get people there? A floating habitat is something that is beyond our capacity right now. The International Space Station was assembled over months, sending pieces bit by bit and assembling it in spacesuits. That's quite difficult to do around Venus. We would really need to send all the parts from here, get it assembled from here. That becomes technologically extremely difficult. And if we send it to the surface of Venus, it's going to burn up. So it's it's the next level of difficulty. So Mars is just a bit easier right now. And it is mainly that Mars is easier. I see there's a CMB question. We will come back to that. Keeping on with the comment, there's a comment from Mito here. We must be sure not to destroy Martian ecosystem if there is any with Earth-based biology. Absolutely. Completely agree. Really, really, absolutely agree with that. And this is a big issue that we really need to be careful of what we bring with us anytime we do space exploration. What is on board our missions and what are we bringing out there? Now, usually space missions will go through a very careful decontamination phase where the outside is completely cleansed and purged and sanitized so that nothing can go with us. But then there's the thing of what are you carrying inside that could go wrong. There was an experiment a few years ago for the moon that exploded upon impact. And this experiment had tardigrades, little tiny space bears, or these little tiny, they're not space bears, these little tiny microbes that have been shown to live in like ridiculous conditions. They can basically survive huge pressure, huge temperature, low temperature, no oxygen, lots of oxygen. They can survive pretty much anything. And there was this mission that had some of the tardigrades on board to see how they would do in space. This mission then crashed into the moon. So the question is, did these tardigrades burn up on impact, or are they now tardigrades on the moon because of human error? And how does that affect the circumstances of the ecosystem that could be present on these places? So if we do send anything to Mars, that's something we have to be extremely careful of, not to bring anything with us, because until we're sure that there's nothing there, and even once we're sure there's nothing there, bringing a creature or any type of life form into a new habitat is extremely dangerous. And this is something we've also seen on Earth. The amount of times colonizers have gone to other planets, or sorry, other countries, and took animals or bacteria or plants with them, intentionally or unintentionally, and the local ecosystem was not equipped to deal with them, and it had really negative impacts. This is something that has taken us a long time as humans to realize not to do on Earth, and there's still mess ups sometimes. When we do this to another planet, the risk is incredibly high. So this is something that absolutely people are aware of, and absolutely people will think of, hopefully very carefully, before doing any type of Mars-based mission. Okay, I see we have other questions. Ivana, I will get to your question in a sec about books. Hello, by the way, I'm not sure if I've seen you here before. Welcome. I will get to the questions I haven't answered in a minute. Sticking to this topic, atmospheric pressure on Venus is like 90 times that of Earth, and the temperature is above melting point of lead. Yes, and this is why going to the surface of Venus is just really, really, really difficult. Follow up by Paul here. The idea of huge orbiting near Earth space station colonies always seemed like the best first step. It's a great launching point for outside of Earth's gravity, well, for the rest of the solar system. Yeah. So, for Earth's gravity, well, yes. So, having space stations near Earth or on nearby colonies is absolutely, if we end up with colonies on other planets, is absolutely a good step, and it's a place that can be used and to kind of bring supplies, to bridge. It would be kind of the pit stop along the way. Again, it's something that technologically is going to be extremely difficult. Building the International Space Station was not an easy endeavor, and it's in our own, it's here, it's in our orbit, it's close by. Building such a thing outside in a different place is something that would be a very useful in between step. If we have, let's say, 50, 60 years from now, there's a Mars colony, it would be really useful to have a space station around Mars that would serve as an intermediate step between here and Mars, kind of the pit stop along the way. Could also be used for supplying in either direction. And then it's a point from there where it's kind of easier to launch missions if you could launch something from the space station, because then you've already got out of the first gravitational hurdle. So some of it becomes technologically easier, but building these space stations, these orbital space stations, is still quite a way away. Follow up from the idea of the two twins, the Kelly brothers. One of the Kelly twins is a few milliseconds older than the other because of time dilation. So we know that when you're traveling at great speed, you experience, or when you're accelerating, you experience time differently to people non-accelerating. This is also the case with gravity. If you're in a place that has a stronger gravitational field, you will experience time dilation. This is something that is shown quite nicely in Interstellar, where if you're on the planet that is close to the black hole, time gets dilated and time passes slower for the ones that stay off of the planet. This is something that is actually true. We have measured this. We know that the people on Earth experience time a bit slower than people on the space station, or people on the space station, because they experience less gravitational force, they will experience time a bit kind of faster than people on Earth. So the twin who went to the space station is a few milliseconds older than the twin who stayed on Earth. Out of the two Kelly brothers, I can never remember which one went up and which one stayed. But out of the two Kelly brothers, the one who was on the space station is a few milliseconds older because of the 1 year he spent on the space station, older than his brother. Of course, then there's the thing that, one of the two twins is going to be older because one of them came out first. But even factoring that in terms of amount of time they experience during that 1 year, one of them experienced a few milliseconds more than the other because of the time dilation. Follow-up comment from Abyssia, I guess, in relation to Venus. There were plans to create floating habitats that could withstand corrosion and have atmospheric pressure equivalent to that of Earth. Yeah, that would be very cool. I think that's something that technologically we're not quite there yet, but it will be very cool if we can do this at some point. I see some follow-ups here about the tardigrades. Yeah, that was a mistake, of course. Yes. Okay, so comment here from Abyss. Scott Kelly was the one that went to the space station. Yes, Mark Kelly was the one that stayed on Earth. Absolutely. So yes, the one who went to space, who was Scott, aged a bit more. The one on the surface aged differently to the one on the International Space Station, which is very cool. It's always very, very cool. I see some more follow-ups there. There's comment from Abyss, still sticking with this. I know there's some other comments, but we're going to stick with space habitats for now. Another follow-up from Abyss here. Astronauts and cosmonauts tend to have inexplicable brain lesions. Really? That is very cool. I have not heard about that. I guess, it really could make sense, right? Because we have evolved to be in this specific gravity, in this specific pressure. Putting us in a completely different environment with no gravity, our whole body is going to be in a completely different system. And yeah, we know it's going to affect muscles and skeleton. It's reasonable that it would affect the brain density as well. And maybe could it produce brain? I'm just like thinking out loud here. Brain lesions in astronauts, cosmonauts could be because, how does your brain tissue adapt to being in an environment that it wasn't designed for? Not really designed, but that it's not been in. This is also something we see on Earth. Anytime there's like a dramatic change in the planet's climate or in the environmental situation, there's always physiological effects. And eventually, if you're in that situation long enough, evolution will kick in, and the humans who can survive that environment are more likely to survive that environment. So then it will naturally select for those qualities that allow us to survive in that environment. But if we're changing our environment from like being on Earth to being in zero G weightlessness or different gravity, it makes sense that our physiology is just not designed for that. And it's something that we really, really have to be aware of and be careful of. Comment from John here. I've wondered about contamination with drilling under the ice of Enceladus. Yeah. So that is the big thing. Enceladus is one of the moons that we have around Saturn. Yes, Enceladus is around Saturn. Yes, I always mix up Saturn and Jupiter's moons. Enceladus is a Jupiter moon. Yes, Enceladus, Jupiter moon. Enceladus has an icy crust, and there's likely to be liquid beneath this icy crust. So it is basically a chunk of, we think there's a rocky layer, water layer, and then an ice layer. This is a place that could have microscopic life forms. It could have microbes. It could have it could be the ideal place to look for other life forms in the solar system. We're talking about microscopic organisms that could live beneath the ice on Enceladus. If we go and drill there are plans to send missions to Enceladus to do experiments there. This is the situation where we have to be incredibly aware of anything we're bringing with us, because the risk is so big. We don't want to be in a situation where we drill under the ice and we're like, hey, we found life forms. Oh no, we killed it. We wiped out the entire planet. This is something we have to avoid. There's a lot of care being taken now with space missions to make sure that this doesn't happen. When Euclid was being built, for an example, which is in no way going to any other planet. Euclid is this very cool space mission that we have that is trying to look for dark matter and dark energy. I've done streams about Euclid. Very cool mission. During the construction phase, Euclid was kept in a clean room. If at any point anyone went into the Euclid mission, they were wearing the full-on, not hazmat suit, but pretty much. The shoes are covered with those nice paper plastic bags, the whole plastic outfit, glass sterilized. And it has to be a purely sterile environment because the risk of introducing something in any of the parts is too big. So they really, really have to be careful with these space missions. And these are ones that are not planning to go anywhere, but they have to plan for what Worst case scenario, Euclid blows up and parts of it crash on an asteroid. What are we bringing to the system? And especially in missions that are going out to look for any life forms, like the ones we're planning to send to Enceladus and Europa at some point, we have to ask these questions of what are we going to bring with us, and what is the risk? And this is something that is really a big concern and a big consideration. And it also comes back to the. So I'm going to go on a bit of a tangent here, but I want to talk about the importance of scientific regulations in doing things like this, because scientists who have been working on this for years, not necessarily just scientists, but things like the European Space Agency, NASA, all of these space agencies have been working for years on planning for this eventuality, on figuring out how to decontaminate their missions, figuring out best practices, figuring out what is and isn't allowed when we go to space. However, space is not regulated. Now, within our planet, we have borders, unfortunately. I'm not going to get into a whole political conversation about the implications of borders, but there are border controls. If you go to another country, you have to go through customs. You have to declare if you carry anything living with you or anything that could be a contaminant, because this is regulated, because people know what you should and shouldn't bring in. And this is because we've seen the effects of bringing a crop that doesn't belong, bringing a predator that doesn't belong, and wiping out whole species. We've seen this happen on Earth, and now there are regulations in place. Space is not yet regulated because space doesn't belong to anybody, therefore space belongs to everybody, which means space is not regulated. When NASA, when ESA do these types of missions, there is careful control. Sometimes mistakes are made, but they try to be careful. What about the private companies that are now sending things to space? Are these subject to any type of regulations? Are there rules in place? Well, was the car that the billionaire sent to space in any way sterilized? Was it space worthy, other than being a gimmicky stunt, which I have many opinions on? So if we're going to allow private companies to take over space travel, sure, there's more money into it. It makes it easier. Okay, fuels the next space race. Companies competing to send stuff to space. But we have to be sure that the regulations are there, because if we start sending stuff to space without these regulations, it's not just about the stuff that we might be sending up there. It's not just about the impact we'll have on other worlds, on other civilizations if we ever encounter them, on other life forms if we ever encounter them. There's also the question of, who is allowed to send a bunch of space junk up there? Who is allowed to send stuff to space that could eventually become a big chunk of metal raining down on the population? And this is something that I feel like the regulations are not as far along as they should be. And again, this is a tangent. I know this was not in any way asked, but talking about, the regulations and the procedures for making sure that we don't bring something with us when we go and drill into Enceladus and look for life forms. These regulations need to be in place for anything going to space, and not just the things that could have a real impact, like missions to Enceladus. There's also the whole question of every step of the way, there needs to be regulations. And private companies sometimes have a tendency to cut regulations, cut corners for profit. And this is something that, when it comes to the space industry, is a risk we can't afford to take. Personal opinion here. So I think we absolutely need to be very careful with the regulations and with the ethics of what we're doing before saying it's a free fall, launch your car into space. What's the worst that could happen? And yes, I am making this about one specific billionaire, but this applies to the overall principle. So, tangent aside, back to questions. I know we've had a lot of cool questions. I'm going to take it from the top, because I know there's been a bunch of cool questions that I haven't answered. This is one of the things I love about Cup of Cosmology. I come on every week. I have no idea what you're going to ask me. Last week, we spent an hour talking about black holes, and now I'm 45 minutes into a discussion about Mars habitat and colonizing space and the ethics of it, because of the questions that you asked. It's responded by one question at the beginning and then the follow-ups. And I love that, because I come on to Cup of Cosmology like, what are we going to talk about today? And it's really fun, and I love the random directions you will take these streams in. Also, my tea is almost cold and my water is still full, which is a sign that I'm not drinking enough. Okay, take it from the top. I'm aware that there is at least one CMB question, which of course I'm going to answer, and a question about a book recommendation, which I'm also going to answer. But taking it from the top, we started with Chapir NASA, Life on Mars simulation, also stuck a David Bowie song in my head. But then there was also a question from James. Could the Big Bang expansion be the outward explosion caused by an earlier big crunch? Does the math rule this out? Excellent question. So I'm going to answer this one quickly, and I'm going to do some quick fire questions and then come catch up and do follow-ups. So we know that the universe is currently expanding. We know that this expansion is accelerating. The universe is growing. It is growing more than it was in the past. When we think about the history of the universe, this is the general picture that we have in mind. I don't know why I still have the first one. I always show this one instead. So we imagine that the universe started as a singularity, kind of an infinitely big, but smaller than it is now, thing that grew exponentially to be the massive thing that the universe is today. So there is the idea that, the universe is currently growing, but the universe constantly has a battle. There is a lot of gravitational force inside the universe. There are a lot of objects with mass that could eventually cause the universe to contract. So there is the idea of, okay, you had this initial explosion. Once the energy of this explosion runs out, could the universe collapse in what is known as a big crunch? Now, if this is the case, it is very easy to imagine a universe that is cyclical. You have the singularity, it expands, at some point gravity takes over, pulls everything inwards, it collapses, you get a big crunch, you delete the whole universe, and then you start again. And you have this kind of almost like a breathing universe, or growing, shrinking. And this is an idea that was very popular 30, 40 years ago because people like the kind of continuity here. It means you don't have to ask about where did the universe start, how did it start, where's it going. It's kind of like the universe has always existed and will always exist, and we have the cyclical process. However, we know that our universe is undergoing accelerated expansion. Not only is it expanding, it is expanding faster than it was in the past. This means that the big crunch scenario becomes slightly less likely because the universe didn't slow down and then collapse due to gravity, but rather it got faster, and the energy from that initial explosion is no longer driving the expansion of the universe. What is driving it now is, we believe, dark energy, which, as I mentioned at the beginning of the stream, we know nothing about, or we don't know much about. But it does seem that the universe, or all of our evidence, points to the fact that the universe is getting bigger and bigger faster than it was in the past. So this makes a big crunch scenario quite unlikely. So then you could ask a follow-up question of, could there have been a previous universe that did have a big crunch and then expanded, and now dark energy has broken the cycle? And that is something we can't really answer because we are limited to the information that is contained within our universe. Anything that may have came before, anything that may come after, is not something we can really answer, because we always say that time began at the Big Bang, at this initial moment. Before then, there was no time, there was no space, there was no up, there was no down. So it's not something we can actually talk about using the mathematics that we have right now, or using the description of the universe we have. So what we can say is the big crunch doesn't look likely as a future possibility, as a future path for the universe now, given the accelerated expansion. Could this have happened in a previous incarnation of the universe? That is a question we can answer within the framework of our current models of the universe. But big crunch doesn't seem likely right now. As to whether it happened in the past, not something we can answer. Okay, going on to questions. Again, I'm just doing quick fire answers now because I spent 45 minutes on one question and derived questions, very cool questions. So just going through. I see there was a comment from Prath that there's a pretty loaded question in the description today of what is time. Absolutely, yes, that is intentional. I kind of noticed the pattern that I put random questions as prompts in the video description, and someone always asks those questions. So now I'm just seeing if that's true. I see that so far no one asked the 3 questions that I put there, but one of them was, what is time? And that is always a fun question because that's not one I can answer. But I put it there as kind of a provocative question to see if anybody would ask that. Okay, there was a comment many eons ago, many boffins ago. Comment from Scott saying Periscope was fun. Yes, Periscope was fun. There were a lot of creeps on Periscope. Yes. YouTube fortunately has better blocking mechanisms, but yes. That I remember the day that I basically got chased off of Periscope by a bunch of creeps and ended my stream after 20 minutes. And that was the day I almost quit streaming. I remember that. And I'm very glad that I came back. But yeah, Periscope had its ups and downs. And I'm very glad that the comment section on the YouTube videos is a bit calmer, a bit more regulated, and everyone here is very nice and very friendly. And those who are not get blocked immediately. I don't have time for trolls these days. I just immediately block. I don't care. I don't have to deal with it anymore. Okay, let's see more comments. We're talking about a lot of the questions about Mars, about the psychological simulations, about Armageddon. Yeah, we covered all of those. Scrolling down, do I think the first person to set foot on Mars is already born? Yes, answered that one. That was a very cool question. I'm just taking it from the top again because there were really cool questions and comments. Okay, got to the question from John that I wanted to answer. That was 32 minutes ago. I ignored a CMB question for 32 minutes. I know there are new comments. I'm currently 30 minutes ago. So if you've just written something right now, I'm not going to answer for a few minutes because I'm going from the top. I'm going to do the CMB question and then we'll catch up. I have a CMB question. Excellent. I love the CMB. Are there any signs of variations in electric charge in the ionized gas that emitted CMB with overdensities of electrons in some places and underdensities in others? Excellent question. Okay, so let's just recap. The CMB, the cosmic microwave background radiation, is the oldest light in the universe, 52 minutes today, almost a record. CMB, cosmic microwave background radiation. This is the oldest light in the universe. This is a snapshot of what the universe looked like 380,000 years after the end of inflation. What you can see here is the background light that was produced at this time. So what was happening then is the universe had three main components. Well, there was dark matter doing its own thing, but there were three main components. There was protons, electrons, and photons, which are particles of light. The universe was very hot, and these particles were constantly bumping into each other. They could not form any atoms, they could not form any stable systems. So you had protons and electrons bumping into each other, and photons bumping into the electrons and the photons, and the protons, just all three of them bumping into each other. As the universe gradually cooled down, the protons and the electrons could combine together to form the first elements, the first nuclei. When that happened, the photons, it's kind of like the electric charge was used up in that coupling. So the photons no longer bumped into them. There were no free electrons for the photons to bump into. So the photons could travel, the particles of light could break away and travel freely throughout the universe. They have been traveling freely ever since. Today, when we observe any direction in the night sky, behind everything else, there is this background radiation, which are these photons here. This is what we see in this map. Now, these photons have been traveling for 13.5 billion years. They have been redshifted, which means their wavelength has shifted to lower frequencies, lower energies. This puts them in the microwave range of the electromagnetic spectrum today. So this is why we call it cosmic microwave background radiation. It's radiation at the background in the microwave range. Now, there is a very cool thing that when these photons broke away, the universe wasn't completely smooth. There were regions that were slightly more dense and regions that were slightly less dense. So there were regions where we had more protons and electrons and regions where we had fewer protons and electrons. And this is actually what gives us this map today. So what we actually see in this map is the temperature of these photons. On average, they are at 2.73 degree Kelvin, which is very cold, minus 270 degrees Celsius, minus 440 degree Fahrenheit if you want freedom units. And this is the average temperature. But what we see here in these orange and blue spots are tiny, tiny temperature differences, slightly hotter and slightly colder. This is also tiny, tiny energy differences, slightly more energetic, slightly less energetic. These are tiny, tiny, tiny differences, but these differences are caused by the universe having these overdense and underdense regions. The regions where there were more photons and electrons, it took a bit longer for the photons to be able to break away and travel throughout the universe. So they lost more energy. So today they are slightly less energetic. So we can really trace the story of this map to these regions that were more dense and less dense in the early universe. So the question you asked, John, of there are overdense and underdense regions with electrons, yes. So where we have these overdensities, we have a larger density of protons and electrons and photons in general. So we have more electrons. Does that mean that there are variations in the electric charge? Absolutely. If you have more electrons or less electrons or fewer electrons, you are going to have these overall variations. However, when we talk about the CMB forming, we're talking about this time of recombination where these things could form the first neutral elements. So once the protons and the electrons group together, we're talking about neutral elements that have been formed. Later on, we do a reionization where we kind of reionize the universe with some light that's happening. And at that point, you get reionization. But you have this process of recombination where you form neutral elements and then these pair up with their ions, so you ionize the universe. This means that the overall charge of these initial atoms, of these initial nuclei, is going to be cancelled out because you are forming neutral atoms. So the question, are there any signs of variations in electric charge in the ionized gas that emitted the CMB? Yes and no. Yes, in the sense that we know there were regions where there were more electrons and regions where there were fewer electrons. When these paired up, we ended up with a neutral gas. Later on, this was reionized. So there are differences, but it's a convoluted answer. And then it gets even more convoluted when stars turn on and add more ions into everything and add more electrons. So short version, yes, but also no, and it's complicated. But that's a very cool question. I'm not sure if I completely answered your question there, John, but hopefully. And if not, let me know. And in any case, it gave me an excuse to bring up the CMB map. Okay, through the questions again. I'm pretty sure I answered all of these. Scrolling through. Question from Sivansh. I'm sorry if I mispronounced your name, Sivansh. What is a good book to start for cosmology and space? Now, it very much depends if you want a pedagogical textbook or if you want kind of an introductory science book or introductory like popular science book. One that I think is amazing to read is The First 3 Minutes by Steven Weinberg, because it really gives you an introduction. It's told in a popular science kind of way, so you can pick it up with no background. And it's told in, it really tells an interesting story of the first 3 minutes of the universe. And the amount of stuff that that book contains, it's 300 pages or so. It's quite easy to read. And it really tells a fascinating story of how things started to happen in the universe. And I think that is a book that will spark a lot of questions, a lot of follow-ups, and a lot of curiosity. So I think The First 3 Minutes by Steven Weinberg is an excellent jumping in point. I think there's a few others of these kind of like popular science ones that are really great to build up interest. Basically, everything Sean Carroll has written. There's also, I would recommend The Disordered Cosmos by Chandra Prescott Weinstein. That is an excellent book about the people, about getting into cosmology. It's like a reflective book about discovering your love for cosmology. There's also, if you want a really fun one, The End of Everything, Astrophysically Speaking by Katie Mack is just a really fun read. It talks about the end of the universe. It will also spark curiosity. Then if you actually want to jump in with a like undergrad level textbook, I would recommend Cosmology by Peter Coles or Cosmology by Peebles. These are both really introductory level books that can answer a lot of questions and also trigger a lot of questions. So all of these books could, I recommend all of these books. Again, feel free to follow up if you, or to ask more questions if you have follow-ups to that. I am going through all the comments. I'm going to jump in where I missed off. I believe I'd answered all of these. Yes, we were talking about astronauts. We were talking about drilling in Enceladus. I went on a rant about a certain billionaire. Okay, again, as always, just a general comment. If you post a comment and tag somebody else's name, I'm just going to ignore it. I assume it's not for me. I assume you're having conversations amongst yourselves, which is great. But then I just skip those. Okay, I've now caught up. I'm now 15 minutes behind, so I now have 15 minutes of questions to catch up with. Comment from Prath. Were the Voyager spacecraft sterilized? I'm not sure about the philosophical implications of anthropogenic panspermia on a different planet. I am not sure. I think they were. There's also the good thing that when you launch things through the atmosphere, they tend to get more or less sterilized, but not always. I do think the Voyager spacecraft was sterilized, but I'm not sure if they were sterilized under the same kind of standards as we have today. Now, the good thing is we've kind of thrown Voyager into empty space. The Voyager missions, we've flung them into empty space, into the solar system, away from the solar system. The chances of Voyager crashing into something is very small. If it were going to crash into anything, it would have been upon launch. It succeeded. So the chances of Voyager crashing into anything are really small. So I'm not overly worried about Voyager bringing any hitchhikers sat on board of Voyager, any life forms hitched a ride on Voyager. But that is a good question. I'm not actually sure if the Voyager spacecraft were sterilized. I would say that it's a low risk if they weren't, but I'm not sure if they were. Okay. Look at Rods from God to see how space was nearly weaponized. Yeah, indeed. Again, we need regulations. I'm all for regulating stuff before we send people to space. Let's see, more comments. I know I'm like 10 minutes behind. I am catching up. Yes. Infinitely big but smaller than it is now is a good description of the early universe and some politicians' ego. Yes, indeed. Some things are. This is the fun thing when we're talking about infinities, that we can compare infinities and we can say the universe is bigger now than it was in the past, but the universe was infinitely big before and the universe is infinitely big now, just a bigger infinitely big, which is something that realistically doesn't actually make sense, but mathematically it does. We can compare infinities. We can actually say this infinity is bigger than that infinity, even though, infinity means bigger than possibly conceivable, and yet we can conceive a bigger infinity, which kind of means, what does infinity even mean? If we can think about a bigger infinity to our first infinity, what does infinity even mean? Mathematics does allow us to compare the sizes of infinities, which is very cool. So yes, the universe is infinitely big now, and it is bigger than it was 13 billion years ago, but 13 billion years ago it was also infinitely big, which is fun. Comment from Paul, CMB image appeared with 7 minutes to spare. Yeah, withdrawal symptoms. I know, right? I get it. The CMB took so long to appear today. I do believe the record was a time when I put the CMB up, a minute 56 of the stream, when I was like, oh, I have not shown you a CMB. And I just flashed the CMB with like 4 minutes to go. So yeah, today was not the longest. There was also once one stream where I did forget and nobody pointed it out. It was like 6 years ago, but there was one stream where there was no CMB. It has happened. Not in modern era Cup of Cosmology, but in classic Cup of Cosmology that did happen. Yeah, the show has been going on so long, I'm going to start referring to it as like the Doctor, where we have classic Who and new Who and new Who. So, we had the Periscope era, we had the HAPS era, and the YouTube era is new Who, new Cup of Cosmology. Again, if you see me swatting at something, it's because I have little flies, because I have an army of plants, and I need to get rid of those. Okay, comment from John here. I didn't even realize you posted topics in the description. Yeah, I do post these prompt questions just because I need a description for the YouTube channel. Often what happens is after the stream has ended, I go back and edit them so that the questions give a vague idea of the topics discussed in that stream. I don't always do this. Sometimes I forget. But I think it's always funny when I put prompts, because these prompts are usually me like setting up the stream 6 hours before I go live, 7 hours, and just like, what questions do I put? And I just start writing the first questions that come to mind. And then it always amuses me the days when people pull out those questions and ask them, and I'm like, that was fun. It's happened 2 weeks in a row. It didn't happen this week. But yes, there are these random questions there. Also, in every video description, there is a link to the Cup of Cosmology Ko-fi where you can buy me a coffee. As always, Cup of Cosmology is free. Cup of Cosmology will always be free. I will never ask you to pay for my content. But if you do feel like giving a donation, buying me a cup of coffee, there is a link at the bottom of every stream where you can do this. And that money goes to covering the cost of running Cup of Cosmology, which is basically the YouTube channel, the website, and the associated things like that. Never any pressure or any obligation, and I do appreciate those of you who do click on that link and send me a cup of coffee. I really do appreciate it, but no obligation. But yes, that is in every video description as well, if you ever want to find that link. Okay, I am almost caught up. There is a comment from Paul here. Watching tip: if you suspect your stream fell behind, set it to 1.25 and it will catch up. Yeah, just coming with a warning. I do speak quite quickly. if you set my streams to 1.25, I will speak even faster. I know some people have tried watching I got a message from a friend once saying, I just tried to watch your stream on 1.5 speed and didn't succeed. So yeah, feel free to put me on fast, but also be warned that sometimes I do speak quickly. I am aware of that. Much slower than I used to. I used to speak a lot faster in the Periscope days, in the original era. Now I'm curious what you all are talking about in the comments, because I just read it and there's comments about tungsten and related discussions, and now I'm curious what you're all talking about. Because usually, just for the sake of my parsing all the comments, I ignore comments that are directed at each other. Sometimes I go back and read your conversations, like, just to see what you're chatting about in the comments, But now I'm curious what you're talking about, tungsten carbide. That sounds like a very cool conversation here. Yeah, sometimes YouTube freezes so you don't realize you're behind. That does happen. Again, I'm behind in the comments, so don't worry. That does happen as well. I could put a reading list on Cup of Cosmology. Yeah, so that does actually somewhat exist. I'm not sure if it's still active. So there is the Cup of Cosmology webpage, cupofcosmology.com. Originally, there was another webpage back in the olden days called there was a blogspot that was blogspot.cupofcosmology.com. And this is so story time. If I'm going to indulge myself here in a bit of backstory. So when I started Cup of Cosmology, the live streams, there was no title. It was just, I'm doing a live stream. It doesn't have a name. It doesn't have anything associated to it. At the same time, I started a blog that was called A Cup of Cosmology. The blog was not updated very frequently, but that blog is where I hosted brain teaser competitions. And on that blog, there was a recommended reading list, or my list of books that I recommend. Now, at some point, I realized that these two things didn't need to be disconnected. So I put them together as Cup of Cosmology. Then there was the name for the live streams. And then I redid the whole webpage. Instead of being hosted on Blogspot, it is now cupofcosmology.com. I own that domain. Again, that's what the Ko-fi covers. Is if you buy me coffee, it covers the domain, among other things. But now that old Blogspot moved to Cup of Cosmology. I have not migrated all the blog posts, but that is an ongoing process. So somewhere on the original Blogspot webpage, there was a reading list. Now, the problem was that it got outdated, because every year there are new science books, there are new science communication books, and I found it quite hard to keep that reading list up to date and meaningful. So at some point, I just stopped updating it, and I put a comment like, this list is out of date. And I'm not sure if I actually just took the list out of circulation at some point because I thought it was outdated. There is an easy way to check this. I'm just going to check Cup of Cosmology, the old blogspot, to see if that page is still alive. Okay, no, that page is no longer visible, but it does still exist. So this means that somewhere I do have kind of an outdated reading list that I recommend for people. If people want me to bring this back, I can do a 2024 edition. I can try to update it and put it on the new webpage, which is cupofcosmology.com. So if enough people want this to happen, I will make it happen. If you do want me to make this reading list, I can do it. Yes, I can try to make a reading list. I'll add it to my long-term plans for Cup of Cosmology. There's quite a few. There's quite a few long-term plans. I know I've hinted at stuff happening and then Paul stuff, but there is stuff happening behind the scenes. There is something coming with Cup of Cosmology. But yes, I will think about resuscitating the reading list, updating it, kind of removing some suggestions that I no longer stand by and adding new ones. And maybe I do a blog post about that on the new Cup of Cosmology that also, has some blog posts. So yeah, there's just a bit of backstory there, because Cup of Cosmology, as I was saying, has had different eras, but the name itself started. So the name of Cup of Cosmology started the same time the stream started, but with different purposes, and then it was kind of united, and then the blog was abandoned, but the name was kept. But yes, okay. I see people happy that I talked about Voyager. A follow-up from John to the CMB question, that I answered most of your question. That is great. You were also wondering about magnetic fields in the CMB plasma. That is very, very cool. That is something that is still a big source of ongoing research, magnetic fields in the CMB. because it's quite hard to isolate the magnetic fields of the CMB from the magnetic fields of everything that's happened in between now and the CMB, and even magnetic fields that might have existed before the CMB, known as primordial magnetic fields, which is a very cool topic that I know basically nothing about. Now, we can try to measure the magnetic field of the CMB, but it is a bit hard to disentangle from everything else. Comment from Prath, let's hope Voyagers don't run into any sneaky primordial black holes. Yeah, but then there is a good thing that space is big. Space is big and very, 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 very empty. Once we've flung something outside of the solar system, the chances of that crashing into something are very, very, very small. Even if there's a primordial black hole there, it is quite hard for things to crash into each other in space because space is very empty. Unless, of course, we fill the orbit of our planet with hundreds of spacecraft and then, is less empty and then crashes become more likely. But there was a comment here from Abyss. I don't think Voyager was sterilized. Contamination control was established after the Voyager space missions. Yeah. It's also possible that Venus might be contaminated with Earth bacteria. That does make sense because we launched spacecraft to Venus before the contamination rules were in place, and we know that these spacecraft were burnt up in the atmosphere. But if any parts of it made it to the surface of Venus, we could have had some contaminants there. That is something that is a possibility. Okay, there was a comment from John. I need a new sci-fi book to read. Sci-fi book recommendation for you all. This is How We Lose the Time War. Excellent book, very, very fun book, quite short, easy to read, about two people on opposing sides of a war. There is very interesting elements to it. There's a lot of cool aspects, and it's just really fun to read. It's written by two authors, and you can kind of see the different voices in it. This is How to Lose the Time War. Excellent book. Highly recommend. It went viral a few years ago, but yeah, there's my sci-fi recommendation of the day. Also, basically anything by Ursula Le Guin. There are some sci-fi books to read. Okay, I like reading the comments out of sync because it's just the comment from James here that just says infinity plus one. And I love it because now I'm thinking like, is that's probably when I was talking about comparing the sizes of infinities, but I just love the message infinity plus one. Yes, okay. As Angie's just pointing out, pointed out 10 minutes ago, you will not let me miss a CMB these days. Indeed, the CMB has to appear. Technically, the CMB does always appear because it is in the Cup of Cosmology logo. It is there. So it always appears right at the start and right at the end of every stream. But yes, I know we all love it when I flash this image. So this will always appear. Has to appear by now. It appears every time. Comment from the Sitter Space here. Is there any chance or planning to add new DESI BAO data to Monty Python? This is a very work question. I am not involved in the DESI likelihoods. I'm not sure, but off the record, yes, maybe, potentially. Feel free to send us an email about that, or open an issue on the Monty Python developer on the Monty Python GitHub. The more people who ask for these things, the more likely we are to do it. So put it there. We had a new Monty Python release a couple of weeks ago with some Euclid stuff. So DESI might happen. If in doubt, Monty Python questions, put it in the Monty Python GitHub page, and the more people who ask, the more likely we are to do it. Work question aside. Okay. People talking about the brain teasers. Yeah. Coming from Prath, I should check if that page is archived on the Wayback Machine. See, that page, I still have access to it. It's in my, if it's not, I think I just removed it from the sidebar, but I could probably still, it's probably still like, if you have the URL, you can probably still access it. And I am actually very logical with the URL, so it's probably not even difficult for people to find. It's like the page still exists. The page of recommended books on the former Cup of Cosmology webpage, it does still exist. It's just not linked anywhere. So, you have to know the URL to find it. You could, if you want to, try to figure it out. But again, I don't stand by that list anymore. But it absolutely exists. It's not like I've lost this page. I can recover it easily enough. It's just not publicly linked for reasons that I decided to remove it from being publicly linked. Comment on the brain teaser competition that I did back in 2016. Comment from Anne saying they were fun but difficult. Comment from Scott saying, I remember doing one of the brain teasers and having a back and forth on why I was wrong, and I'm still not sure I understand it. Well, feel free to message me again about that because those brain teasers were super fun. Yeah. Um, okay, I caught up to the questions. I am only 15 minutes over time today, but I caught up to all the questions. I don't know why at some point I decided if I can, I will answer every question or every comment, or at least acknowledge it. I think, you will take your time to ask questions, to come to the shows. And the whole point of Cup of Cosmology is it's interactive. And I might not be able to get to your questions and comments every week, but I do try. And I think, if you spend 2 minutes of your life to type up a question, I will try to answer it. And I don't always succeed. And I do try, but I don't always succeed. But I think I managed to answer all the questions today. And again, I love the random directions that Cup of Cosmology goes in. I did not expect us to be talking about Mars missions and space exploration for like 90% of the stream or 75% of the stream. But it is very cool. This was the first question that I read and we just ran with it and you all had follow-ups. And I love it because I don't prepare much for these streams. Unless I have a topic, I just come and like, let's see what we're going to chat about. And it's great fun because it forces me to think about random topics that I don't normally think about. And I love the type of questions you will ask. Also, I want to point out, last week, someone asked an amazing question. We were talking a lot about black holes last week. And someone asked the question last week of, do white holes have Hawking radiation equivalent? I just want to mention that I have discussed this with multiple colleagues at work this week, and we have still not reached an answer. There's a few more people I need to ask who are currently on holiday, who are actually experts in black holes and can probably answer. But pretty much every coffee break this week I've started with, so I have a physics question for you all. And we still have not figured out an answer. So I love that. I love that there was a question on Cup of Cosmology that now has physicists baffled. We generally are like, cool question. So once I figured out the answer to that, I will absolutely tell you. But for now, we're like, white holes, Hawking evaporation? Cool question. So I can't remember exactly who asked that. I have 2 or 3 names in mind. So I can't remember who asked it, but it was a brilliant question. And it's a question that's led to a lot of conversations at work this week. And physicists are baffled. Yes, Prath, it was you. Excellent. Thank you. Yes. So that was an excellent question. You have baffled physicists. Once we figure out an answer to that, I will absolutely let you know. But that was fun. That was fun. That was a very cool question. And I like when you ask difficult questions that I don't know the answer to. And especially if it's a question that then my colleagues also don't know the answer to, because now we're like, how do we even calculate Hawking evaporation in a white hole? How? Math? Weird. Yes, that was a brilliant question. And I'm still slightly confused by that question. So I'll let you know once we answer that, because that was cool. Okay, an hour and 20 minutes. The last 3 or 4 weeks, I think now, actually, every stream I've done in the last 3 months, I've gone over 1 hour, and not just a bit. These streams are supposed to be 1 hour. We're at 1 hour, 20 minutes. This is a 30% increase. These streams are getting longer, which is great fun, except for the fact that normally, so for me, it is 9 p.m., 20 past 9. Usually, I have dinner and then do the stream, because that's just how I've planned my Sundays. But now, today, I actually have not yet had dinner. So I thought maybe I do a shorter stream today because I am hungry. And yet, an hour and 20 minutes later. So I should go get some dinner. A comment from Obisi. I remember the first time I ran into you on Periscope many years ago. So strange that every aspect of my life has changed over the last 7 years. But so glad you're still doing this. Yeah, thank you, Abyss. Thank you for that comment. It's also, on a personal note, Cup of Cosmology has been a constant in my life for the last 9 years. And my life today is very, very different to how it was 9 years ago. Just thinking about the amount of things that have happened in that time, the amount of things I've gone through, the amount of things the world has gone through. Cup of Cosmology is still here somehow. It is probably the biggest commitment I've had in my life. 9 years is a long time. Cup of Cosmology has outlived several relationships by now, which is a fun thing to think about. But yeah, I started Cup of Cosmology during my master's. You all saw me through a master's degree, a PhD, on to my second postdoc. Yeah, Cup of Cosmology has been a constant in my life for 9 years, and I really do appreciate the fact that it has been for some of you as well. And I've had some gaps. There was a whole year where I just stopped streaming, and I'm so glad that I came back to it. And I love that I can take gaps and come back, and you're all still here. And there's new people, there's old people, there's newcomers, there's people who've been here for months, there's people who've been here for 9 years. I think it's amazing. And you still surprise me with the questions. 9 years in, and I still get questions like black holes, white holes, Hawking evaporation, questions that I've never even considered. And I love that. So really, genuinely, thank you to everyone, because you are all what make Cup of Cosmology what it is. This is an interactive stream. So Cup of Cosmology is what it is because of your interactions. So yeah, it is it is very, very cool. I love all the questions you ask. I love the interactions. I love the comments you send me, the emails. Even if I don't answer, I do appreciate them. So just generally, thank you to all of you for making Cup of Cosmology this 9-year constant in my life. It is good to have some type of continuity amongst the chaos of existence. On that note, Cup of Cosmology should be back next Sunday. I don't think I have anything coming up. I have a few empty Sundays now coming up instead of the busy Sundays that I had the last few months. So Cup of Cosmology should be back next Sunday. Same time as always. That is 8 p.m. if you're in Finland, 7 p.m. if you're in mainland Europe, 1 p.m. if you're on the East Coast of the US, 10 a.m. if you're on the West Coast of the US. As always, there is a time zone converter on the webpage, cupofcosmology.com, where you can figure out when the next stream is in your own time zone. Please do click there if you don't know when I'm next live, click there. If you subscribe to notifications on the YouTube channel, you will be notified 30 minutes before I go live, so then you can get a reminder. You need to have white hole information paradox live. Yeah, you will get an answer to the white hole question as soon as we figured it out. For now, it's still baffling us. Scientists baffled. So, Cup of Cosmology should be online next Sunday. Either next Sunday or the one after. So within the next 2 weeks, I will do a stream about the paper that I put out last month. I just need to see if I'm grabbing any of my co-authors to join me for that. But that's going to happen very soon. And then there's other streams coming. And again, there is some Cup of Cosmology stuff bubbling behind the scenes that you will see eventually when it's ready. So yeah, Cup of Cosmology next Sunday, same time as always. I hope to see you all then. And I hope in the meantime, you'll stay safe and take care of each other.